Welcome to lesson 4. In this lesson, we are going to explore our future STP, RSTP, and VLAN topologies, in which we are going to use trunks, PAGP, bondings, LACP, bondings, or Ether channels. I have built for you this specific topology in order to test RSTP, STP, and all kind of VLAN and trunking and PAGP and LACP configuration that you may expect in your real life or on the CCNA exam. So let's start. In this topology, we have router 1, switch 2, switch 3, switch 4, and switch 5. Router has 4 interfaces in its configuration. Switch has 8 interfaces in its configuration. You should choose Ether port groups 2. Each group has 4 interfaces inside. All the configuration is on the factory default settings. I didn't change anything other than the router 1. On router 1, I have set the startup configuration from the previous lab. I just copied the configuration from the previous lab and pasted it here. The only difference I set is the Ethernet interfaces. On the previous lab, we had Ethernet 1 looking to the internet, and in our case, Ethernet 0/3 is looking to the internet, and 0/0 is looking to the LAN side. So based on this, the startup configuration is as the following. We have the same DHCP pool, no changes here. We have Ethernet 0/0 is not inside in this case, instead of outside. And we have assigned the same address range. So the only difference is that Ethernet interface, which looks inside, is different with its IP configuration. Then we have Ethernet 0/3, which looks in our topology to the internet, and I have changed the last 4 letters of the MAC address to AAA, and the rest I left the same, like IP DHCP client and IP NAT outside. There is no enable password. The login local is set, but we haven't specified the usernames here yet. And that's all. So after you paste this configuration to the EVNG, you switch this one on. After you switch this one on, you right-click on the router and say wipe. And after wiping, you say start. And when the router is being started, it will read the configuration after the wipe from startup configuration from this config. As you can see, we have other switches which are blank. Why? Because I didn't save anything to them. Let's start the rest devices like switch 1, switch 2, switch 3, switch 4, and switch 5. I have also added the tiny Linux computers to the Ethernet 3 port of each switch. As you can see, we have on the schema the trunk planet links. These links are just regular links. They are not trunks yet. We are going to convert them into trunks in upcoming lessons. Currently, we are going to explore single subnet configuration without any VLANs. Then, if you can see here, we have trunk planet with the PAGP bonding planet using 2 links for the PAGP, which is CISCO proprietary Ether channel. Then here we have also a trunk with LACP bonding planet, which is IEEE standards-based bonding, which is supported by the majority of the vendors, or we can say all of the vendors. And here we have also trunk planet. So these 2 links will have a LACP bonding and PAGP bonding, and we will explore what is the difference between them and how to set them properly. Then in the future, we are going to use the links which are mentioned by trunks for the VLAN tagging. So these Ethernet links will be used for VLAN tagging or trunk links, as the CISCO names suggests. So far we have 5 switch in our topology. You can see that we have 2 rings, one ring here and one big ring here. The reason that we have used here 2 links, let's say that this is not a PC5, but let's say this will be FTP server. Because this is FTP server, the reachability to that server is of high importance, and we have created links from other switch to that switch with additional protection. This additional cable protection in upcoming slides will be converted to the PAGP link and LACP link, which will be protection and at the same time double capacity. What we are going to do now, we are going to set up the rest switch configurations, like for switch 1, switch 2, switch 3, switch 4, and switch 5. We are just going to change their default name to the ones that we are planned. For example, if we right-click on the console, we see that its name is just switch, but we have to enable it and say configure terminal, like we did previously, and say host name is SW1. Then there is one more thing, because these are the new switch images. Let's see the images. Do show version. Because these are 23-year images, the default configuration which comes with those switch is not STP like in old packet tracer labs, but it is RSTP. And in order to go step by step, we first want to test the STP configuration instead of RSTP. So we will convert those switch to STP. For example, let's say do show spanning tree detail. And as you can see here, it says VLAN 1, which is the only VLAN that we have in our lab, is executing RSTP compatible spanning tree. We want it to be STP first. That's why we say spanning tree mode. And we have 3 options: MST, multiple spanning tree, which we are not going to explore in this course, PVST, per VLAN spanning tree, which is a standard STP mode, and rapid PVST, per VLAN rapid spanning tree mode, which is active now. We will convert to the old mode, which is PVST. Let's copy this command so that we can use it on other switches. It says, warning, changing STP mode can disrupt the traffic and make system unstable. Recommend to change STP mode only during maintenance window. It's okay, we are in the lab configuration and those disruptions are not critical for us. And we say do write, and let's check if the configuration is changed to spanning tree. Yes, you see it says VLAN 1 is executing the IEEE standard compatible spanning tree. Okay, that's all for switch 1. Let's go to switch 2. Enable. Configure terminal. Host name SW2. And then we paste PVST. Okay. Let's copy this command. Okay, and we say do write to save the configuration. Then we go to switch 3. Enable conft hostname SW3. And then we shift it to mode per VLAN spanning tree, which is old STP. Then we say do write it. And then we can shift to the next switch, switch 4. Enter. Enable. Configure terminal. Configure terminal. Hostname. SW4. And we paste the spanning tree mod per VLAN spanning tree, and we say do write. Then we go to switch 5. Enable. Configure terminal. Hostname SW5. And we paste the configuration of our switch, say do write. Now let's go and check again from first to the last switch what are the configurations we have there. Switch 2, switch 3, switch 4. Okay, let's say exit and say show spanning tree detail. And we see that is executing IEEE. It's okay. Switch 2, exit, show spanning tree detail. This one is also IEEE. Let's check for switch 4, exit, show spanning tree detail. This one is also IEEE. And the last one, which we have changed the configuration last, show spanning tree detail. And this one is also using IEEE. So we have 5 switch configured. All of them are using spanning tree old technology. Let's power on one of the computers and check if we have a connectivity from this computer to the internet via this router. Let's open the computer configuration window. This is PC4. Let's say DHCP if it's able to acquire the IP address from our router. And as you can see, it has acquired the first address from the DHCP pool. Let's say ping google.com. And as you can see, it can ping the google.com. So what we have checked in this lab, that the lab is working. So next thing that we are going to explore in this lab is the bridge ID. Recall the sequence of our criteria that STP uses to choose the path. So in order to understand what is the path topology created here, after we switched on all the switches and all the links are on, we should know the lowest bridge ID of the topology, lowest route path cost, lowest sender bridge ID, lowest sender port ID. Port IDs are generally equivalent to the numbers of the Ethernet ports that we see on the switch. So if the Ethernet port has a lower number, the port ID is also lower. But the bridge ID is a combination of the bridge priority plus MAC address, which we have to find out and write it. For example, here on switch 1, I have already written, it's not visible with the small letters until it's zoomed in. So let's zoom in. Zoom in. You can see that I have written here the bridge ID priority 32,769. The priority itself is 32,768 plus 1. 1 is the VLAN 1. So if you have multiple VLANs in your system, then the bridge ID of each spanning tree of each VLAN will be different. Why? Because it will add to the bridge ID the priority plus the VLAN number. Together, the bridge ID is being communicated between switches using this format. For example, here we have 8001, which is 32,769 in hex, plus the MAC address. Let's check how can we find that bridge ID. We look into the switch 1. By saying show spanning tree, we can find out the switch 1 bridge ID. Show spanning tree. Let's make it larger. As you can see, we have just VLAN 1 or one VLAN in our current setup. We don't have multiple VLANs. That's why the system shows only availability of one VLAN, which is VLAN 0001. We have a root ID of 32,769, and the MAC address of that bridge is AABBCC002000, which I wrote here, and together the bridge ID in hex here. There is a different way to see the details. We can see detail, and then you can see the information about each port, which is a little bit excessive in our case. We need bridge ID. And as you can see, it can give us directly the bridge ID here. Okay, let's copy this value from here to this label. For this, we have to duplicate current labels to here, then duplicate to here, then duplicate to here, and duplicate to here. So far we know the bridge ID only of the switch 1, so let's find out what is the bridge ID for the switch 2 and update it accordingly. Update accordingly our labels. So we say show spanning tree bridge ID. As you can see, it is 8001 AABBCC 003000. So the MAC address of that bridge is this one, and the bridge priority is the same. So let's copy it. We can just update maybe the number to 3000 here, because the rest is same. And we should update the MAC address to 3000. Let's check the switch 3. Switch 3. We say exit, show spanning tree bridge ID, and it ends with 4000. So the priority is same, just the MAC address ends with 4000. Let's update it here. $4,000 here and 4000 here. Then we go to switch 4. Control cancel and say show spanning tree bridge ID. And we see that the bridge ID is ending with 5000 here. Let's change the MAC address to 5000 and 5000 here. And the switch 5 is the last switch in the system, in the topology. We say show spanning tree bridge ID, and it ends with 6000. We say 8001, AA, BB, CC, 00, 6000. So the last portion of the MAC address is only different. Let's change it to 6000 here and 6000 here. Okay. Let's zoom out. After we zoom out, the writings on the labels are not visible. Even I feel difficulty reading them on my 4K screen. But when required, I will zoom them in so that we will see them all together. Now we know which MAC address belongs to which switch and what is the bridge priority set on each switch. We have fixed them and noted them with the labels, as here. We have set the configuration to STP instead of RSTP, and we have changed the name of the switch in the CLI. Plus, we have updated our router configuration so that it can distribute the IP addresses via this port to all this topology. And we have tested that the PC4 has a connectivity with the internet, most probably through this link or through that link. We will check what this exactly the link is on our next lesson by exploring the STP topologies. And when we will explore, we will put these labels on each of the link to identify if it's a root, if it's a designated port, if it's an alternate port, if it's a backup port, or if it is a disabled port. That's all what I wanted to show you in this lesson. If you have any questions, you can write them in the comment section of the video. See you in upcoming lesson. I highly recommend subscribing to my YouTube channel so that you don't miss any new lessons or setup guides that I release.